On your mark, go. Today is the last lesson of this unit. Today we're going to talk about function inverses. So we've talked to you that there are some different operations known as addition, subtraction, multiplication, and division. Yesterday we talked about a new operation. What was the operation we talked about yesterday? Start with a C. Composition.
So close. Close call there. Close call.
And I told you guys that there's certain things that you can compose and certain things that you can't compose. For example, can I compose two numbers?
No.
Can I compose two functions?
Yes.
Yes, absolutely. So there's certain groups that you can work these operations with, and there's certain groups that you cannot work these operations with, okay? So our operation today is called inverse. It's a -1, okay? And a function inverse, f inverse, it does not mean 1 over f. That's not what it means, okay? Doesn't mean that at all. But it turns out there's only certain types of functions that you can find the inverse of. And those are functions that are to be what we call 1-to-1. A function is said to be 1-to-1 if every element of the domain, anybody, corresponds to exactly one element of the range.
Isn't that just good job?
Say it.
Definition of a function. Yeah.
Definition of function. And
Are we serious right now?
we are serious. And here's where you gotta make sense of it, okay? So you understand what the heck is going on. Okay? Addie and Kira are playing soccer. Okay? Addie scores 1 goal, Kira scores 4 goals. Is that a function?
Yeah.
Absolutely. Addie scores 1 goal, Kira scores no goals and 2 goals. Is that a function?
No, it can't
No, she has to have just one output, right?
be. Yeah, one.
Okay? How about this? Addie scores 2 goals, Kira scores 2 goals. Is that a function?
Yeah, it is.
Yeah, they can output the same amount, right? But suppose I asked you, which one scored 2 goals?
Both.
They both did. Then that's not 1-to-1. So if I can't tell from the output what the input exactly is, then it's not 1-to-1. Now if I said that Addie scored 9 goals and Kira scored none, and I say, who's the person who couldn't score a goal? You would say,
Kira.
Kira.
I'm just kidding. She doesn't stick.
Okay, so there we go. That's 1-to-1 because they each have one output, and that output only has one input. Do you see that? So every element of the domain corresponds to exactly one element range, and every element of the range corresponds to exactly one element of the domain. So it's the definition of the domain kind of written twice, just domain to range,
Flipped.
range to domain.
Flipped.
Okay? So we'll do a graphical example.
Oh, snap.
Is that a function?
Yes.
Because it passes the
Vertical line.
vertical line test. So what that means is if I pick out, say, the number -2, it outputs a value of, say, +3. But is -2 the only spot on the graph that has an output of 3?
Yeah,
Isn't that right there also an output of 3?
Oh. Yeah.
So therefore, this is a function, but it's not 1-to-1. A 1-to-1 function must pass the vertical line test and the horizontal line test. function's 1-to-1, it passes the vertical line test and the horizontal line test. That one fails, doesn't it? If I draw a different function that looks, say, like this, both of those are cubics, okay? Does the red one pass the horizontal line test? Yes, so it is 1-to-1. 1-to-1 is important because 1-to-1 is the set of functions that we can find the inverse of. So let's get to the big deal today, which is talking about what is an inverse. Inverse does not mean we flip it upside down. Inverse is the following. Inverse of a function means that all the domain values change to the range values, and all the range values change to the domain values. Or in other words, all of the x's become the y's, and all of the y's become the x's. They exchange. So I'm going to give you a very, very boring function, but it's a function nonetheless. And the function is going to be 1, 2, 3, 4. That's my function. It's 2 points. Everybody agree it's pretty boring?
Yes.
Very boring. But we're still going to do some work with it. What is f of 1?
2.
2. That means if I have an x value of 1, my y value is 2. Everybody agreed? What is f of 2?
1.
Do I have an x value of 2 anywhere?
No.
No. So I don't have an output for f of 2. What is f of 3?
4.
4. Because I have an x value of 3 that outputs 4. Everybody agreed? So now watch this. What is f inverse of 2? That means if you have a y value of 2, what's the corresponding x value?
1.
1. What is f inverse of 3? If I'm given a y value of 3, what's the x value?
Don't have one.
There is none.
It's already 3.
What if I have f inverse of 4?
3.
4 is the y value, 3 is the x value.
Bam, the finger goes.
So that's a function inverse in its most basic form, which leads us to our first example here. We'll do the other pieces in a second here. Given f of 2 is 3, f of 1 is 9, f of negative 3 is 8, f of 4 is 5, and f is 1-to-1, find the following. F inverse of 8. So I look at this, and I say if I have a y value 8, the x value is?
Negative 3.
Good.
Oh my gosh, man.
F inverse of 3, I look here. If y is 3, x is 2. F inverse of 5, 4, and 1. Okay? That's the basics. Suppose we change it a little bit and we say given f of x is 3x minus 8, find f inverse of 6. Shoot, I'm not given a point there, I'm given a function. That means if I have a y value of 6, how do I come up with the missing x value? Anybody have a thought?
Graph it?
What did you say? Tell me more. How? Equal to? Equal to?
0.
6.
Negative 6.
We're going to take the y value and make it 6. So we're going to say if the output is 6, what would the input have to be? Everybody see that? So I add the 8 and I divide by 3 and I get x is 14 over 3. So it's about finding the x. In example 3, it says find the inverses of the following functions. I have 2 functions here, okay? And instead of giving a value to come up with, I have a function I'm going to come up with. So this one is y is equal to 2x minus 5. In order to find its inverse, I switch the x and the y around. So I turn this into x equals 2y minus 5. And once I switch it, I then solve for y. I'm going to add the 5 and I'm going to divide by 2. You could write it like that, or you could write it as y is equal to 1/2 x plus 5 halves. Either way is just fine. But that's my inverse.
Okay.
Take out your calculator.
Oh, I love Can I see your red python?
I just want to see it.
Paradise, any word from Danica?
Oh my.
You think she'll bring back us some souvenirs? Probably not. Okay.
Maybe like
So disappointing.
Stop.
No, it really might be good.
I'm gonna think of it.
Probably
Everybody knows.
Batteries.
He also doesn't have socks.
Everybody knows.
What I'd like you to do is let's type in those two functions. Our first one is 2x minus 5. And then I'm going to type in the inverse, which was 1/2 x, or x over 2. And it was plus 5 halves. And then what I'd like you to do is I'd like you to go down and just type in an x, y equals x. Here's what's interesting. Y equals x is a line that looks like this. Agreed? And notice that what we're doing is we're switching the y and the x values when we find the inverses. Watch what happens with the graph as I go zoom 6 or zoom standard. What's interesting about this is the inverse is flipped over the line y equals x. I started with the blue one. The inverse is the red one. It is reflected over the line y equals x. It's not reflected over the x-axis. It's not reflected over the y-axis. It's reflected over this. So look at the blue one. It crosses through the y at -5. This one crosses through the x at -5. The blue crosses through the x at 2.5. The red crosses through the y at 2.5. Notice how they are perfectly reflected over, and that's a great way to check your answer. And so, as we look at our notes, the point is this. Graphically speaking, they are reflected over the line y is equal to x. And that's going to be important for us to use moving forward. Let's work on finding another inverse. We're going to do a couple more, and we'll check one of those on our calculator. For this one, I have y is equal to 2 minus x over 3x minus 4. So we switch and we do x is equal to 2 minus y over 3y minus 4. How is this different from the previous one? It is a fraction, but what is going to make this one more challenging?
There's 2 y.
There's y's in 2 different locations. That's not what we had before, and it will make it a little bit more difficult. We are going to write this over 1, and we are going to cross multiply. X times 3y is 3xy. X times -4 is -4x. That's equal to 1 times 2 is 2, and 1 times -y is -y.
Sick.
Notice how you have y's in 2 locations. I taught you this back in your very first unit, and I told you you would be on your test.
Can I guess?
About 80% of you did a good job with it, about 20% of you didn't. Here's now your opportunity to redeem yourself because you have to be able to know how to do this. I want to be able to isolate to just one y. So therefore, I'll gather all of my y's on one side. So 2xy plus y. And everything that doesn't have a y will go on the other side. Anybody remember what we do in this case to make it 1y instead of 2y's?
What's the word for it?
So there's an F, it rhymes with actor.
Factor. You factor it. That was good.
Or factor out a
Y.
y, and we get 3x plus 1 is equal to 2 plus 4x. Now that I have y times that, what can I do to both sides? We're going to divide by 3x plus 1. So I get y is equal to 2 plus 4x divided by 3x plus 1. We're going to pause just to break things up a little bit. I want you to turn to your homework, and you should be able to actually start working on your front page. We're just going to take about a 4-minute break, let you kind of do some stuff on your own, and then we'll go back to the second part of these notes. So it should say function inverses, and you're ready to do anything that sits on the front. You should be able to get a decent amount done in 4 minutes, okay? Go ahead.
So, how would I do
How many think of it?
We're going to take the inside, which is the square root of x minus 1. Make that greater than
So something back to stuck in your head, bro.
So it's not a normal inequality. It's a non-linear.
I don't think any of them are 1-to-1.
I know that shifted to the right one.
How is that one?
Right.
I know.
This one is. This one is.
I'm not sure about the first one. I think the first one is.
The first one is.
No, it's
She doesn't pass the horizontal line
Oh,
behind that spot.
exactly.
Well, that would be where it's.
Because when the arrows come back down, like that. No.
The tippers are coming out.
What?
Square root side to get x
There's none 1-to-1.
Actually, the
No,
second,
no,
the
no,
second
that-
one
that's
might
what
be.
that-
No, it's not.
I just thought where it crosses.
Is it?
It's not.
No,
No, it's
no,
not.
when you go here,
To
you
infinity.
touch them.
Ah? Wait,
That's when they're stuck.
isn't the third one?
a question
No.
yesterday?
Oh, because the vertical line does. But the horizontal one passes though. Does it not?
Vertical passes.
Or sorry, yeah. The horizontal doesn't.
It's, so, I mean, it's a function, but it's not 1-to-1.
It's not 1-to-1.
What I
Well, more like that.
situation.
One-on-one.
That's took a shot at it.
Circle it. So x over x plus 2. That's that.
Everybody
X
knows.
over x plus 2 plus 2.
What's the thing? Is it just?
So now you're just doing the denominators.
Oh,
Multiply by 2. Better?
how would I say
Or 2A.
So that one,
Oh, wait.
I forgot how to do this.
I just feel like there's more I could do here. But really, I don't think there is.
So you do have
There
multiple
should be
square
a
roots,
minute.
which is a thing.
The first one not just.
What? 2? I don't know.
About 2 more minutes, we're going to move on.
Holy smokes, I have no clue what I'm doing.
Wow.
It's okay, Rich. We'll figure it out.
Dredge,
Can we do the number 3?
honesty is better than not being honest.
Oh, yeah, that's right. You don't know how to do 3 yet. Let's get to that.
Or A, B, C, D, E, or
Well,
F.
Ledge might know how to do it.
The sledge knows how to do it.
He's smart.
So if f of 2 is 7, what that means is that you have the coordinate
2-7.
2, 7. So if you're wondering, F inverse of 7. That means if you have a y value of 7, what's the x value?
2.
Okay, flip over to the next side of your notes.
What? Oh, he changed it up.
I'd like to change this problem to just 2 minus x cubed.
Back.
Flip the page, Hammond.
This is y is equal to 2 minus x cubed. What I'm going to do is I'm going to switch the x and the y values. So this becomes x is equal to 2 minus y cubed. Again, the goal is to solve for y because that will be the inverse. Somebody help me out.
X minus 2 is equal
Good, subtract 2 from both sides.
to negative y.
Do I cube root or do I divide by negative 1? Divide by my negative 1. And so I get 2 minus x is equal to y cubed. That's square root what? Cube root. So the cube root of 2 minus x is equal to y. That's that.
The cube root of 2 minus x is equal to y.
I want to save time here, so I'm not going to plug this entirely into the calculator, but we do know what that graph looks like, don't we? It's a cubic that is shifted up 2 units, and it's upside down. So everybody agree it looks basically like the red?
Yep.
So then, we also know what that looks like, don't we?
Yeah.
That's shifted to the right 2 units. 1, 2. And it's flipped upside down, so it looks like.
That's.
Do you agree that
Yeah, I don't know.
those look like they're flipped over the line y is equal to x?
Uh-huh.
Yeah, and so we can always check our inverses that way. All right, most important problem today is that you focus on letter D, okay? And what I have here is I'd like to find the inverse, okay? But I'm going to do a little bit of investigative work ahead of time to help you make sense of it. Because many people will just switch the x and the y, and they'll come up with the wrong answer. And I want to show you ahead of time why that is. Let's do a little bit of investigative work right away. I'm going to just think about the graph for a second. What does that shape look like?
So the line that trails off.
Good, it's one of those things. And what's the shift that happens here?
It goes to
Left 1,
left 1.
up 4. Good. So I'm going to go left 1 and up 1, 2, 3, 4. And I get the red. I'd like to express the domain and the range of this so I can gain some understanding about it. Domain is going to be from -1 to infinity, and the range is going to be from 4 to infinity. Everybody got that? So, even though I have not found the inverse of that function, I already know ahead of time what the new domain and range will be, because they simply swap. The new domain is going to be from 4 to infinity, and the range is going to be from -1 to infinity. Everybody agreed? I already know that without doing any other work. Now let's actually find the inverse. I have y is equal to 4 plus the root of x plus 1. When you find the inverse, what do you have to do? You switch the y and the x, right? X is equal to 4 plus the root of x plus 1, or y plus 1, excuse me. I want to solve for y. What do I have to move first? The 4. X minus 4 is equal to the root of y plus 1.
You square it.
Square both sides. I have the quantity x minus 4 squared. I'm not going to multiply it out because we know how to graph these when they are in vertex form. And finally, I subtract 1. What shape does that make? Parabola. Vertex form, shifted to the right 4 units and down 1. Everybody agree? So I'm going to go ahead and I'm going to move to the right 4, I'm going to go down 1, and I'm going to check out this graph.
That ain't it.
Anybody see something wrong here?
It's not the same.
Yeah. Notice what these guys are saying is if you take that red and reflect it, you don't get that shape, do you? So what just happened? This incredible thing that happens in math, I love it. We'll focus a lot more on it as this class moves forward. But notice how I went to 1 degree. Notice how I squared both sides and I got 2nd degree. What happens, you added an extra side than what you wanted. Also, is this green? Does it pass the horizontal line test? No. So this is not a one-to-one function. When you squared both sides, you created something that wasn't one-to-one. You want to get rid of one of these sides. You think I want to get rid of the right side or the left side? I want to get rid of this. I don't want that there. So yeah, I mean, if I'm drawing a graph, I can just cross it out. But how do I say I want this graph here, but I only want that part of it? Well, what you do is you just restrict the domain. We say we only want it from 4 to infinity. So we want that with 4 to infinity. And now we have just that side of the function. So I love that example because it teaches us how to find the inverse. It talks about the domain and the range flipping, and it talks as well about the reflection. Okay,
So,
that was,
But they're
yes.
still gonna.
so if you put the domain there, it just kind of cancels out the left side.
What it means is if you are looking at that function, I'll do a real basic example here so that we're really clear about it. Suppose that I have y is equal to x squared, okay? Would you agree that that looks like this?
Uh-huh.
Well, now I'm going to graph y equals x squared for a domain of 0 to infinity. Well, that graph is just going to look like that. I've said I only want that half, and that's what we've done.
Okay.
Okay, good question. All right, flip back once more. Question.
So they'll still cross at some point, though, right?
Yeah, if you look at that example that we just did, if you were to draw the line of y is equal to x, it will, it's this one flipped over that line to get there. So they do cross, yep. But we don't have that portion. Okay. All right, last piece. This is the pickup from yesterday. You guys already know it, so it's nice and easy. If we want to test to see if something are inverses, what we do is we compose the two functions together. If we want to test to see if two things are inverses, we compose them. And when you compose them, if it produces x, they are inverses. But because composition is not commutative, you have to test it both ways. F of g of x and g of f of x. If they both produce x, they are inverses. And this makes sense because, for example, in addition, -3 and 3 are what we call inverses because when you add them together, you get 0. And in multiplication, 1/4 and 4 are inverses because when you multiply them, you get 1. So 0 is our additive inverse in addition. This is our multiplicative inverse multiplication. This is our function inverse, which is x, our composition piece. So let's work that out together. As we flip over, use the property of inverses to determine if these are, in fact, inverses of each other. And when it says use the property of inverses, this really means I need to use composition. That's what this means. So I'm going to show that 3x minus 5 and x plus 5 over 3 are, in fact, inverses. I will compose f of g of x, and I will compose g of f of x. I need to see this work on the test. For 12 years, I've put up with subpar work. I will not put up with subpar work this time around. I want to warn you guys, okay? I'm going to show you the way that kids have done it in the past, and for this, I will now just take off points right away, okay? This is the work I need to see. I'm going to take G, I'm going to plug it in right there. So what I want to see you write out is I have 3 times parentheses, x plus 5 over 3, and then a minus 5. Everybody okay with that? You tell me now, what can I cancel off first? The 3 over the 3 or the positive 5 and the negative 5? Do you know which one I can cancel first? The 3 over 3, because I have to do my multiplication first, don't I? So those reduce, and so I end up with x plus 5 minus 5. And what is x plus 5 minus 5? X. Isn't that what I was supposed to come up with? Absolutely. You showed me which cancels first. This is sufficient work. Now I'll do the next one. I would take this 3x minus 5, I would drop it in for the x right there. And so I get the quantity 3x minus 5 plus 5, all divided by 3. You tell me which ones do I cancel first here, the 5s or the 3s? The 5s, without a doubt. Okay, these are grouped together in the top. I have to first take 5 and negative 5, and when I add those together, I get 3x over 3. Now I can take 3x over 3 and divide it, and I get x. You got x for both of them, so yes, these are inverses. Can I now show you the work that people show me on the test sometimes, for which I will not give you credit? This is the work that I get. If you're like, oh, it all crosses up, I get x. I did it all in my head. I don't care. I ain't giving you any credit for that. Okay? Not going to try to find 1 point in there, 2 points in there, half a point. Don't give me that cross-off stuff. You just write the next step and then write how, I need to be convinced that you know which one reduces first. We all got that? Okay, good. Yeah. All right, we're almost there. You guys are doing well. We're going to try to get 2 more in here. We have f of g, and we have g of f. I want you to take a minute. I don't want you to try to reduce them, but see if you can just write them composed. See if you can write them composed to see if they're in the right spots, if the numbers and the variables and everything are in the right places. People make mistakes with this one. Right, eyes up and check. Did you have the plus 2 in the denominator? It needs to be in the denominator. And then do you have this minus 2 off to the end? It needs to be off to the side. It can't be in the denominator. Okay, so the question is here, okay? Do I flip the x first or do I cancel out the 2's first?
You cancel out the 2's first.
I cancel out the 2's, and this gives me 1 over x. That's my next step. What is 1 over x?
X.
It's just x. That worked. Look at the next one. Do I flip the x plus 2 first, or do I cancel off the 2's first?
Flip.
I flip this first. And so I get x plus 2 minus 2.
How do you cancel off the 2?
And what is x plus 2 minus 2? X. So yes, these are inverses. Our last example. Good job getting through a longer lesson. Promise I will respect your time on Monday and Tuesday. Wednesday you have your test. We have f of x is 4x squared, g of x is the root of x over 2. I have f of g of x, and I'm going to do g of f of x. Notice that there's this little addition here. It says for x greater than or equal to 0. Notice that it's 4x squared. Is 4x squared a one-to-one function? What shape does that make?
Parabola.
Is a parabola one-to-one?
No.
No. If I restrict the domain to be just this half, is it now one-to-one?
Uh-huh.
Yes. So that's all that means. You don't have to do anything with it. And so if I take this and drop it into x, I get 4 times the quantity, root of x over 2 squared. So in this situation, again, I don't want you to just cross stuff off. I want you to decide. Do you first multiply by 4 or do you first square?
Square.
I square, and I get 4 times x over 4. And what is 4 times x over 4?
X.
X. So yes, that does satisfy the inverse. And then the last one, I'm going to take 4x squared and drop it in there. And I get the root of 4x squared, all divided by 2. Do I start this one by dividing by 2, or do I first take the square root?
Take the square root.
I take the square root to get a 2x over 2, and that ends up being x. So please make sure that you're paying attention to the order. Okay. Yes, these are inverses. Great job. You have everything you need. You have a weekend in front of you. You have some time to get some work done. I would love to help you with anything that you have questions on. No, I can see that. My point is that I don't mind if you cross something off along the way, but without a doubt, I would say it is very common for people to